Hello, everyone. Today we are going to go through the next part of the module 4, measures of central tendency. We are focusing on discrete random variable, and then we are trying to understand how to measure the central value of that random variable can take, or the distribution-wise, what's the central value. So the first one we want to talk about expected value. Now, in here, I define a little bit more other things like row moment and central moment. So let's go back to the expected value. Expected value can be calculated using this formula. So here, mu, which is a Greek letter, okay, and then this is expected value. And it can be calculated using this formula. So what is expected value? Expected value is the one you would see in long run. So it's basically the long run average. You can claim it as long run average. Of course, you can see that by multiplying these probabilities, remember the sum of probability is what? 1. So by multiplying this, you are taking essentially weighted average. So this is kind of like a weighted average. The weights are coming from probabilities. Okay. So that's called as the expected value. Now, expanding this idea, you can calculate the kth row moment using this formula. So you can see that the kth row moment is expected value of kth, if x is the random variable, kth power of that random variable. This one is not changing, okay, even though the power of value is changing. For example, you can have a distribution table like this. X can take like x1 all the way up to xn. Okay. Then you have probability x equal xi. Now, when you come to the kth power of that random variable, yes, these are going to change. Okay. But the probability it taking this value is still same. Okay. These are going to be same. So just notice that you don't have to recalculate the probability xk taking xik. Okay. So this is same as probability x to the k taking xik. Okay. That's same. So this is the kth row moment. And you can also calculate something called the central moment. So here mu is the expected value. We calculated it earlier. And then you take the kth power. And then that's going to be what? If I use the same definition. And then the probability x taking xi. Okay. So of course you can see that if I use k equal 1, this is going to be 0. Okay, so if k equal 1, this the first central moment is going to be end up as 0. You can check it. Okay? So therefore we define this for more than k equal 2. When k equal 2, the second central moment called as variance. We are going to learn about that next. So this is more like the central moment you can use to measure dispersion, which we are going to learn in the next lecture. Okay, so here you can see example. You are given probability distribution function of random variable. So here you have probability x equal xi, and x can take either 1, 2, 3, or 4. And this one is 0.4, this one is 0.2, this one is 0.3, this one is 0.1. Calculate the expected value. So let's write the definition. Sigma xi times probability x taking xi. So x can take 1, The probability for that is 0.4. X can take 2. Probability for that is 0.2. X can take 3. Probability is 0.3. X can take 4, 0.1. And then you can add these. And then you can get the answer. So it's going to be, I think, 1.8. You can calculate the second moment. So for that, you need x square. Okay. So so x need to be squared 1. It can take 4, 9, 16. Now you can multiply the probability. So you can see that it's going to be 1 times 0.4, 4 times 0.2, 9 times 0.3, plus 16 times 0.1. And when you add, you would get what? You can see 1.6 plus 4 is 2. 2 plus 2, 4, 4.7, plus 8, 5.5. Check it. And the same way you can calculate the first central moment of x, which is basically x minus mu. And it's going to be 0. You can but check it. You already know the mu. What is the mu? This is mu now. So basically you have to create another column, x minus mu. So mu is 1.8. So 1 minus 1.8 is going to be negative 0.8. 2 minus 1.8 is 0.2. 3 minus 1.8 is 1.2. 4 minus 1.2 is 2.2. Okay. Then you multiply each one of these with the probability and see what you get. Okay, so then the second central moment, for that you have to create another column, x minus mu square. Okay. Then get the expected value using the same approach. Now, what happens if you have function which depend on x? For something like y equal, let's say x square plus 2x plus 3. Okay. X itself is random variable. So therefore, y is going to be random variable. Okay. So then if someone asks what would be the expected value of y, so let's say this is a function of random variable x. So I need to calculate expected value of gx. Okay. So it's still same idea. Okay, so you can use the same approach. In this case, it's going to be what? X equal xi. And probability for that. So so you can find the expected value of that new random variable. Here you will see some linear properties of expected value. If a, b are two constant, and if you want to get the expected value of ax plus by, then you can use this nice formula where you use linear property. Okay. For example, if you have something like this, yeah, if you are constant, then it's going to be plus b. Okay. Why? Because the expected value of constant is itself. Okay. So here you can see we are using that properties to get the expected value. So expected value of x is 5. So if I write expected value of y, which is expected value of 3x plus 2, and that's going to end up as 3 times expected value of x plus 2, which is 3 times 5 plus 2, which is going to be 17. So I will leave this for you to try, and once you do it, please contact me and we can check whether your answer is correct. So that is what we discussed so far is called as expected value, the long run average. Now, there are some other measures we can use to measure central tendency. One is called the mid-range. The mid-range calculated using maximum and minimum divided by 2. Another one is mode. It is defined as the value that occur most frequently. It can be situation where you can be in situation where there are more than one mode. So it can be unimode, bimodal. So multimodal is depend on the distribution, depend on the data set. For example, let's say you have like 1, 1, then 2, 3, 4, 5, 5. Then of course you have a bimodal distribution. Median is another measurement of center. You arrange data in increasing or decreasing order, then you find the middle point. So it can be the two middle value divided by 2, or just the middle value, depending on whether you have even or odd numbers. So let's say if you have 1, 2, 3, then this is the median. If you have 1, 2, 3, 4, then the median would be 2 plus 3 divided by 2. The median is actually 50th percentile. You can expand that idea and get percentiles. There are different formulas actually to calculate percentiles. Some textbook use some fancy approach, but here you have one type formula. You may see different formulas, okay, by the way. So according to this formula, you can calculate the nth percentile by like let's say you want to get the ith percentile, then it's 100 times I divided by n plus 1, then the xith data point would be the that percentile. Okay. And then you have the quartiles. Basically, that's 25th percentile, 50th percentile, and 70th percentile. These are special names in a way, but in general sense, that's percentile actually. Okay, so you can calculate those two. So 50th percentile is actually median, or we call as a second quartile. Okay, so here you can find the mode. What's the mode and which one of the most? You can see 5. Median, let's design increase in order, so I can just find the middle value. That would be 5. Mid-range, max plus min divided by 2. So 11 plus 1 divided by 2, which is 6. 30th percentile. So if I go to the formula, 100i divided by n plus 1. Okay. So in this case, 100 times 0.3. How many data points we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is going to be third data point. So it's 3. And Q3 is actually 70th percentile. So you have 100 times 1.75 divided by 10. That's going to be 7.5th data point. So in between these two, you can take middle value of those two if you want. So that's it's depend on what kind of interpolation technique you use. Okay, so that's the end of measures of central tendency. Our next lecture would be about measures of dispersion.